In the last video, we took a look at the networking stack, kind of all the different layers that make it up, and then the basics of the transport layer, and then a little bit of focus on the pros and cons of TCP and UDP. Before we start coding, I want to go into a little bit more detail about how the networking process actually works, how the different layers interact with each other. Reason being that this is what a socket is, so that when we say socket IO, the socket part, you'll have an understanding of what it actually is instead of just a cool name. It actually does refer to something. That, and you've got this super cool image from Wikipedia that you can lay claim to understand a little bit of. Now remember, I am not a network engineer, so I definitely cannot turn you into a network engineer. I'm a developer, and this is a developer's approach. So if this is interesting, you can ask questions, but proceed at your own risk. It's a lot of fun to do research on this stuff, and you'll find yourself going down the hole pretty quick because there's a ton of really cool stuff out there. But I had shown you the 5 layers that make up a packet, and there's actually a 7-layer model as well. I'm using this one though. So there's the application on the top, there is the transport right below it, and this was, I mentioned, HTTP, there's also FTP, there's SSH. We're going to use primarily HTTP. I'm assuming that you come to this with a knowledge already of HTTP. If you don't, you're not that familiar with it or whatever, I have put the video from my Express course at the very end here, which is just a supplemental video. If some of the stuff in here doesn't make sense or you just need a refresher on HTTP, you can go and watch that. For the transport layer, it's primarily TCP and UDP. And then there's the network layer. And the network layer is primarily the IP protocol or the internet protocol. IP protocol is redundant. And these two work together, TCP IP, which you would have heard of before. There's the link layer, which was the Wi-Fi or the Ethernet, and then the actual physical layer. Okay? These layers represent all the different parts of the networking stack. The browser, as well as Express and Flask and so on, they all use HTTP to manage network traffic. So as data is passing back and forth between two different machines, whether it's server to server or browser to server or whatever, they are talking via packets, and the application layer that they're using is HTTP. Okay? Now we're still going to use HTTP, but WebSockets and Socket IO will use TCP. And I'll go into detail on this later. I'm going to refer to both WebSockets and Socket IO in this section somewhat interchangeably. Now, WebSockets would be the native technology that's actually part of JavaScript, and WebSockets will allow you to connect to a server's socket via TCP rather than HTTP. So WebSockets would be the native browser protocol that we're talking about here. Socket IO, on the other hand, does the same thing. It allows you to try and connect to a socket on the other computer, but it comes with a bunch of advantages so that if this doesn't support WebSockets, Socket IO can fail over to other things, specifically long polling, which we'll talk about later. But as an analogy, Socket IO is kind of maybe like jQuery. So as jQuery is to JavaScript, sort of Socket IO is to WebSockets 10 years ago. When jQuery first came along in 2006, it was so awesome because it standardized DOM manipulation in a day when we had tons of browser problems to worry about. Socket IO kind of does the same thing for WebSockets, but they're not the same thing. We'll talk about that later. Before we jump in too deep, why we're talking about this, I will show this at the end, but everything on your computer that's running is considered a process by the operating system. Somehow or another, a thread has spun off or whatever, and you've got different processes running on your machine. All of those processes have sort of like a tube coming out of them that they can bind on a port, and out of that thing can come and go data. Not a real physical tube, of course, it's just an idea. This is the socket, and the data is what we're about to talk about. This is what's going in and out of that socket. The reason we're talking about this is because we're going to talk about Socket IO. This is the socket part, right? We're going to talk about WebSockets. This is the socket part, okay? The socket is the networking part, and we are going to send data through that socket by connecting to it via the means we are about to go over. So let's say that we have an HTTP message, and hopefully you know how this works already. But an HTTP message comes with a header, and it comes with a body, and there's a blank line in between. That's beside the point at the moment. Okay, the header provides metadata about the body. Okay, and metadata is a fancy term for data about data. Okay, as a quick for instance, a common header is going to be content type. Okay, what are examples of content type? Well, the one that you probably use all the time, whether you know it or not, is text/HTML. This right here gives us information about what's in here. Hey, you're supposed to treat it like text/HTML. Okay? Another option might be image/PNG. Don't treat what's in here like HTML because it's not. It's a PNG file. So it gives us data about the body or about the data, about how to treat that packet or about how to treat this network thing. What's the cache or cache control? What's the date? What's the protocol I'm supposed to use, etc. Okay, so now if we go down to the transport layer here, TCP also has a header. Okay, and inside of that header, you can quick Google TCP header if you want to see a little bit more visually what it does, because my drawing skills only extend so far. But like we had talked in the last video, it will have the source port inside of it. It will have the destination port inside of it. It will have some kind of sequence number. There's a sequence number will let who's ever on the other end where this packet is supposed to fall in the stream of data. Remember, TCP guarantees that the packets will arrive as well as they'll be in the correct order. So that's what the sequence number's for. There's also an acknowledgement number. Okay, so kind of like an HTTP header, there's a bunch of metadata inside of the header that's going to provide information about the data that's actually in the body. What is the body? Well, the body of this layer, of the transport layer, is going to be the entire application layer message. Okay, so the entire HTTP message in this case would be the body of the TCP message. But the TCP message will have its own header. All right, you get to the IP, okay, and it will have its own header. And the IP header is going to have the source IP address, as opposed to the port, which is what we had back on the transport layer. It will have the source IP. It will have the destination IP. Okay, that's how it knows where to go. It has some other things, a checksum and so on. What's the body of the IP layer? Well, hopefully you saw this coming. The entire message from the transport layer will be the body of the network layer. The link layer also has a header. They're getting progressively smaller, by the way. For its given frame, it will have stuff like the MAC address, okay? And the body, hopefully you saw this coming too, is going to be the entire network frame, all right? And then the physical is going to be the same way, where this whole thing is going to go in the body of this, all right? So the way that it's actually layered is like nesting dolls. The physical layer has its own header, and it also has its own body. And inside of its body, we'll put physical up top here in a different color. And then the link layer here will have its own header, as well as a body. And that body is going to be the entire network frame, which will have a header and a body, which will be the transport, and I ran out of room, so we're just going to stop there because that's where TCP stops anyway. Strictly speaking, the physical layer, this is a little bit more complicated. We're just going to leave it as a header. It totally depends on how you approach it, but for our purposes, it's fine to just call everything header. The physical layer does not care about any of this. It only cares about its own header. I don't know what any of that stuff is. It's for somebody else. Okay, the link layer doesn't care about any of this. It cares about its header, but it doesn't care about anything else. That's for somebody else to deal with. The network layer doesn't care about this body. It's for somebody else. I only care about my header. All right? So at the very lowest level, what we have is an Ethernet cable or something connecting to devices. I'll put here Ethernet 1, and I'll put over here Ethernet 2. So we have two different things that are connected through some kind of physical layer. All right, and I'm going to put here physical, right? This is just pulses of electricity. All right, ones and zeros going across the wire really, really fast, and it's really just electricity, okay? Now, the headers, it's really cool. We just don't have time to talk about it. But figuring out what on earth this ridiculous little series of electricity and or ones and zeros, what belongs to what? How do I keep everything straight? It's super cool. You'll have a bit that's dedicated to, hey, this is the first one. Hey, this is the last one. We don't have time to talk about it. Maybe in another course. But let's say the request is coming from Ethernet 1. Well, up at the top, we have app, if it exists. An app will send its stuff down to transport. Transport will send its stuff down to network, or it gets packaged. Again, we're talking about this in very vernacular terms here. And that will go down to link. And then finally, it will hit the wire. Well, it will go across the wire, right? Data, streams of data are going back and forth. It will come out, and it will slowly get stripped out, right? The body will get stripped out of each one and sent up to the next section, which will grab its own header all the way back up the line in reverse order until eventually it hits something that actually does what you want. Okay? So that's networking. That's networking for developers in like 15 minutes. So we are going to use this application layer, which is going to be an HTTP request. It's going to have its own header, and it's going to have its own body. We're going to use that plenty. That will hand itself off to the transport layer. But once our HTTP message is done doing its thing, we are going to use the transport layer to do all of our WebSocket work. I found this great image. I don't know anything about microchipdeveloper.com, but this image was fantastic compared with my drawing, and hopefully it will be easier to see. I just wanted to make sure that they got credit for their cool image. The application layer on top has its own header as well as its own message, right? I want to download a web page from this address. That entire thing gets added to the body of the transport layer segment, along with its own header, which specifies the source port and the destination port. This entire thing, which is this header plus this body, gets added down here as the body of the network layer packet, and it has its own header with the source IP and the destination IP. This whole thing, which is this body plus this header, which is this body plus this header, gets all added to the body of the link frame, along with a header that has the MAC address and so on. And this whole thing gets sent to the physical layer, okay? So things are slowly falling over until finally you get to the end of the chain, all right? This is what's going in and out of the sockets, okay? A network socket is an open stream of data that gets this passing in and out of it. All right? So just a real quick recap. We have the layers. You kind of understand how they interact with each other. We are going to use WebSockets and Socket.io to do this. We're going to have our client, and we're going to have our server. All right? With Socket.io, out of the box, that means this is a Node module. There's actually a Python version of Socket.io. There's a C# version, etc. Those are maintained by the community. But we're going to have a Node server most of the time, and usually the client is going to be a browser. It might be something else. One of our projects will be two servers talking to each other. But the client will initially make a request to port 80 or 443, secure or insecure, it doesn't matter. That will establish an initial HTTP connection. Once we've got everything set up, the Node server will specify a port on your computer. It will be an arbitrary port. It makes no difference. It'll just be a TCP or UDP port that we can use. And then we will open up a socket from our computer to that computer that is all TCP, and data can freely flow back and forth, back and forth, back and forth. Unlike HTTP, once we're done, this will get disconnected. And if we wanted to make, say, an AJAX request again, you'd need to go hit it, right? It would respond, and then that would be closed. You wanted to make another AJAX request, you'd hit it, and then it would respond, and that would close, right? With WebSockets and Socket.io, TCP is going to remain open, and you've got all those layers working together to make this magic happen, okay? When I take a step back and look at this, I am totally shocked that it works. Not that it's not awesome and not that great people aren't doing it, but there are so many errors that could possibly happen across all these layers that it absolutely blows my mind that the internet works every day. I mean, I get really mad when my internet doesn't work for even a minute or if it's slow. This is a miracle, or magic if you prefer. All right. So again, that's networking in a total nutshell for a developer. I hope that as we go into all the WebSocket stuff and start coding, you'll have this as a frame of reference for whenever I mention TCP and HTTP. They are different, but they work together. TCP is a little bit lower in the stack, and HTTP provides more application level support, but we get to keep the connection open with TCP.